Hi folks, welcome back to 4.6 part 5. And in this video, we're going to take a look at what it takes to solve log equations that use log properties. All right, so all the stuff that we learned from 4.5 is going to now be useful and I'll zoom out for a moment. You see that we now have equations that have more than one log. So example 15 has 2, example 16 has 2, example 17, we got 3 logs, all right? So things are about to get juicy. We're going to combine some different concepts and see where it takes us. All right, let's take a look at example 15. So I've got log base 8 of x plus log base 8 of x minus 12 equals 2, okay? Now, what I'm going to do is I'm going to go ahead and combine the 2 logs on this side using the product property, okay? And so that means that I have log base 8, and I'm going to use a bracket here just to show that I'm taking this quantity and multiplying it by this quantity. So x times x minus 12, right? So log base 8 of everything in the bracket equals 2. All right. And so let's note here that we use the product property to condense. And what do we have now? Well, we have our unknowns. We have a base of 8, and we have 2, which is going to be the power that we raise the base to, right? So what we've done here is we've actually isolated the log, but instead of using regular algebra, we used our log properties, okay? Now we're going to go ahead and rewrite this in exponential form. In other words, x times x minus 12 equals 8 squared. All right, so here's my power, here's my base, and here is my unknown. All right, so this, my friends, is our rewrite in exponential form, okay? And now we just need to do some good old algebra. We're going to distribute, we're going to see what we have and go from there, all right? So I'm going to distribute, I get x squared minus 12x, and 8 squared is 64, right? Now I see a quadratic, right? I see that x squared and a linear term and a constant. And so I'm going to think back to what do I do when it comes to quadratics? I'm going to move everything to one side, set it equal to 0, and factor, right? So x squared minus 12x minus 64 equals 0. And off to the side, I'm going to set up for how I might split this middle term, right? We're looking for a clever way to write negative 12x so that I can find the greatest common factor in 2 different clumps. So a times c is negative 64, b is negative 12. So I'm thinking about numbers that multiply to make 64, but also add to make 12, all right? Now, 64, it turns out that 16 and 4 multiply to make 64, right? But how do I make them add to make negative 12? Well, put a negative sign in front of that negative 16. Now I can write this as x squared minus 16x plus 4x minus 64 equals 0. Right? So I've cleverly expanded that first term or that middle term. And now I can clump the first 2, clump the second 2, look for those greatest common factors. All right, let's move over here so we have a little bit more room. Now, the greatest common factor for the first 2 terms is x. And the greatest common factor for the second 2 terms is 4. So I end up with x times x minus 16 plus 4 times x minus 16 equals 0, which is x plus 4 times x minus 16 equals 0. Now I can set each one of those equal to 0. X plus 4 equals 0, so x equals -4, or x minus 16 equals 0, or x equals 16. Now, before we put that victory box around those and say, yes, those are both answers, we need to plug them back in. But where do we plug them back in? Do we plug them back here? No, that's not where we started. We got to go all the way back to the beginning. Literally what is typed as the problem. That's where we plug in our numbers. Now, I'm going to leave that up to you, but I will tell you that 16 is an answer, but x equals -4 is not. And it's important that you know why that -4 is not an input, okay? Yeah. And if you're not sure, it might be useful to go back and think about some of the other questions in here. In particular, maybe example 9, how we talked about why that is not an actual answer, okay? All right, so before we move on, let's be patient. Let's make sure we've got all of our work here on the screen for 15, all right? But a good way to use the properties to help us solve more complicated looking equations. All right, let's move on to 16. Take a look at 16. Again, I see a log and another log. And even though they have the same base, I can't just cross those out because I have this +2. Now, normally we think, oh, +2, not a big deal. But if it was only log 2 that we were plussing, then we might take a different strategy, okay? Or if it looked like this, log equals log, then we could cross those out. So what I'm going to do is I'm going to take this log and I'm going to move it to the other side, okay? And when I do that, I'm going to get log of 5x plus 1 minus log of 2x minus 3 equals 2. All right. Now, unlike 15, this is not a plus sign. This is a minus sign. Because it's a minus sign, I don't want to use the product property, but rather I want to use the quotient property. Okay, so not the product, but the quotient. What does that mean? It means I have log of 5x plus 1 over 2x minus 3 equals 2. And why did I leave such a big space here? I want to set myself up for success. I know I'm going to have to write this in exponential form, and it's so much easier if I could find the base 10, okay? So we have our base, we have our power that we're raising that base to, and then we have our unknown, okay? And so now we're going to go ahead and rewrite in exponential form, okay? And when we do that, we will end up with the following. 5x plus 1 over 2x minus 3 equals 10 squared. All right, so our unknown becomes equal to our base raised to the power, okay? Now, I'm going to do a few things here. I'm going to take the 10 squared and I'm going to turn it into 100. And I'm actually going to do 100 over 1 because I can make any whole number a fraction by putting it over 1, okay? So that's going to give me 5x plus 1 over 2x minus 3 equals 100 over 1. And now what I'm going to do is I'm going to cross multiply, okay? So let's move up here. And the cross multiply, I get 5x plus 1 equals 100 times 2x minus 3. Okay. Linear equation, I don't even have to worry about factoring. Distribute, 5x plus 1 equals 200x minus 300. I'm going to subtract 5x from both sides, and I'm going to add 300 to both sides. (301) equals 195x. Last step, divide by 195. Okay. And I'll leave you to check that and make sure that it is correct, all right? But I'll tell you a hint. If we plug in this number, as long as we don't end up taking log of a negative number, we're usually going to be fine, okay? So as long as the thing in the parentheses isn't negative, then you'll be fine. All right? So let's take a look at the two that we've done so far. We've done number 15 and number 16, both using log properties, but in slightly different ways, okay? Let's move on to the last example where we now have 3 logs. All right. So here's what we can do. We have a few different strategies, all right? So I kind of want to talk through them, and then I'll choose one to do. So option number 1, we keep this over here, and we take these two and we use the product property to bring them together. Option two, we take this one and we move it to the other side. Now we'll have 0 equals 3 different logs, and we can combine them using product and quotient property. Okay. I'm going to choose the first way, where I just combine the logs on the right-hand side. So I have here log of x minus 1 equals log of, all right, I need to take this 2 over x and multiply it by 3x minus 5. Bracket 2 over x times 3x minus 5. All right. Now, here's why I chose this way. I got a log base 10 on this side, and I got a log base 10 on this side. This is just like the ones we started with back in video 3. They're logs with the same base. That means we can simplify this to be x minus 1 equals 2 over x times 3x minus 5. Pretty cool, right? We've combined our logs using the product property. And now we have the same basis, so we were just able to get rid of the logs altogether, okay? All right, so I know that our algebra skills are a little rusty, and I want to make sure that we're going through this step by step, okay? So the first thing I'm going to do is I'm going to take this x, and I'm going to multiply it to the other side, all right? So I've got x times x minus 1 equals 2 times 3x minus 5. Now I can distribute, and I'll get x squared minus x equals 6x minus 10. Looks like we've got a quadratic. I bet it's going to be factorable, so let's move everything to one side, set it equal to 0, and solve. X squared minus 7x plus 10 equals 0. All right, let's set up for our factoring. 10 and negative 7. All right, these numbers are a little bit smaller. That's good. We want numbers that multiply to make 10, but add to make negative 7. So negative 5 and negative 2 will get us there. X squared minus 5x minus 2x plus 10 equals 0. And this negative 7x became that part, right? Now we clump our first two and our second two, and we find the greatest common factor. So the greatest common factor of x squared minus 5x is x, leaving us with x minus 5. But the greatest common factor for the second piece, that negative 2x plus 10, is actually negative 2. That leaves us with x minus 5, right? Now, we've done an example like this before, but I just want to point out that we need a minus here because we're multiplying it by a minus, and we need to get back to a plus, okay? Now, these two match, which means that we are able to fully factor. And then we set each one equal to 0. We get x equals 2, x equals 5. And before we put those boxes on there,